Hello,
Casey.
everybody. How's it going?
Good news.
Pretty good. Waking up. Just finished my coffee. Just gonna give a few more minutes for folks to show up.
Good morning.
Hey, Jerome.
Hey, Casey. Hey, Lance. Hey, Pedro.
Chris, are you there? Probably not. He's probably just getting off of Calico Live, so give him a minute. Does somebody want to be my note taker in the meantime?
I would, but I'm busy reviewing Eloise's PR here.
Okay, I can volunteer if I have access to the Google Doc then.
Sounds like a fair trade to me.
Yep.
Let me link the meeting docs, meeting minutes. Cool. Yeah, why don't we get started? This is, what is today? Today's April 13th. And this is the Calico community meeting. I'm gonna start off as usual on some check-ins and updates. So I think front and center is the 323 release, which is in its final stages. We're targeting this month for that. So probably looking at sometime around the 25th, just based on where we're at right now, going through final bits of coding and test over the next couple of weeks, and aiming for code freeze sometime early next week. So it's good that Sean's getting a review in on that PR. Hopefully we can get that merged before code freeze. Big things there. We're looking at IPv6 support for VXLAN mode, which is exciting and something we've been hearing about for a while. We have updated our Istio integration to use CSI for handling the volume mounts instead of the flex volume driver that we had been using before. and VPP going to beta, which is also a big one. A lot of work going into that, so very exciting. Other small things as well. Wanted to call out an improvement to the IPAM Prometheus metrics, which is exciting as well. Gives a little bit more flexibility in how you view those. So I think it adds some additional labels to those metrics and adds one or two other metrics as well, just for tracking how IPAM's working. Those are the big things. Like I said, that's coming out in a couple of weeks. We've also got some operator work going on. Eric can't be here, but he gave me a couple things to talk about. So we're working on IPv6 cluster migration from manifest to operator. There were a few bits of config that weren't handled properly or at all in that process. So should have support for migrating from a manifest install that's either dual stack or IPv6 only to an operator managed install very shortly. And then we've also got some additional scheduling options in the works. I think we've heard from quite a few people that, especially for Taifa, being able to set affinities and node selectors to decide where that lands and how it's scheduled in the cluster would be useful. And also for Calico node in certain circumstances. I think it's one that we held off on for a while because, I mean, it's a big foot gun. You can tell Calico not to run on some nodes, and then those nodes aren't going to work. But there were some legitimate scenarios where you wanted to restrict or control how that was scheduled. So keep on the lookout for those. Sort of relatedly, 323 is going to tweak the operator's Helm chart a bit as well, so that when you're installing via Helm, you can pass the -- namespace option. It's a minor thing, but it does have some upgrade implications, and it means that we kind of just a more idiomatic Helm chart. The Helm release will be installed in the namespace that the operator is installed instead of always being in the default namespace. So I know Helm purists are excited about that. I think those are the main things for updates. I got some issues to talk about later as well, but I'll save those. Sean, did you have anything you wanted to say about eBPF land?
I think we have a brewing issue, which is newer versions of Kubernetes and Docker are starting to use cgroup v2, and they're starting to isolate that, and that's kind of making a brewing issue because right now Calico assumes that it can access the root cgroup v2 hierarchy, which is only true if the containerizer is not containerizing that, and it used to not be possible to containerize that. So we need a workaround for that, and we have one in the works, but it's not out yet. So if you move to a 2.new version of Kubernetes, you can get trapped with that not working properly. So yeah, working on that. Also
is
working
it Kubernetes? Sorry, is it
Sorry.
Kubernetes version related or kernel related?
It's more like the specific configuration of like Docker or Containerd or Creo or whatever that underpins your Kubernetes. I'm not 100% sure on exactly when you end up with this, if it's like a thing that's dependent on, say, the distribution and when the distribution decides to turn on that option, or if it's an operating system. It seems to be a little bit random. I'm not exactly sure what circumstances, but yeah, we're hoping to work around it shortly and put out a fix for that.
Cool, that's good to know. Yeah, it sounds something that is maybe correlated with Kubernetes version, but also correlated with a bunch of other versions.
Yeah. I think other work that we have in progress, we just started on IPv6 support and made a few other enhancements. So a few other kind of knocking some rough edges off, like we've got configuration for the map sizes that we use now. So like if you're on a big system or a small system, you can tune the sizes of BPF maps and things like that. Little quality of life improvements. I think we're also like making sure that the Linux contract table doesn't activate for a lot more flows than we were before. So setting no track on the flows, which helps with avoiding like dual tracking, which is not ideal. So yeah, a few things, a few enhancements and things going on now.
Cool. Thanks, Sean. Why don't we talk a little bit about what's going on the VPP front?
Hi.
Whoever wants to chime in, just probably like a status update on
Yeah.
on beta
Yeah.
and so on.
I can do a quick update. I don't know, my internet seems quite unstable.
You're coming through good for me right now.
Okay. Because all of the videos are frozen. So, so a quick update on VPP. So we are still making progress in tracking down the bugs, so which has been mostly our activities in the last part of our activity in the last month. We have reached a point where we are mostly close to whole grain CI. Just one or two small things remaining, but that should be fixable by fairly soon. So we hope to be beta quality enough to be able to make it in the 3.23, hopefully. So we are full steam on this to being able to reach that status, and found also a couple issues also in the CI / the integration with the X data planes. So we're keeping working on that. And in parallel, we're also making more exploratory work on the ability to expose multiple network interfaces in pods. So Hades is working on this, and I think there is a demo scheduled soon.
Yeah, are you guys ready to demo a little bit of that today, I think?
Yes.
Nice. Cool. We'll get a nice look at that at the second half of the meeting then. Any other updates anyone wanted to share? If not, I've got some some issues to talk about. I feel like I'm losing my voice this morning. I'm gonna share my screen. I've got a few new issues that have come in that I just wanted to take a spin through and do a first level of triage on. Got too many windows open as usual. Yeah, so this is actually one of the issues that I think has come up in a few different ways. We've had a number of users reporting that Calico suddenly starts getting connection unauthorized errors from the CNI plugin. And we've seen a few different manifestations of this. I know Lance looked into one, or a couple of them, but discovered the root cause of one, which is that I think in Kubernetes 1.21, service account tokens are automatically invalidated when the pod is deleted, so stopped running. And so since the CNI plugin uses the same service account token that Calico node does, if you happen to evict Calico node from a node for one reason or another, that will mean the CNI plugin loses its credentials to talk to the API server. So some instances of this are that root cause. I don't think that this one is, because there's no indication that the node is being evicted. So I think there's some other service account token changes that may be relevant here as well. So this one's still under investigation, but wanted to call it out because I think it's been starting to show up more and more.
I think someone was proposing a PR or proposing to raise a PR along these lines.
Yeah, so I think there was an idea to stop sharing that token, which seems like a good thing, and instead call the token request API directly. So we could kind of keep that token up to date and refreshed ourselves without binding it to the life cycle of Calico node. I think that's probably the right fix. Hopefully, yeah, I do remember that comment. Someone had suggested they would have a go at implementing that, so that would be nice. If not, then I'll try to squeeze it into the next release because it's a big one, I think. This one, actually, I've already been digging into, but don't have a solution yet. So I'll just assign this one to me. I think that probably not much to talk about here. They're seeing out-of-date rules on the node, and we've already eliminated. There was a known issue in an earlier release that had this sort of symptom, so this might be something different. Add disk and network usage metrics to Felix. Yeah, maybe. It sounds like they just want to integrate the existing node exporter functionality into Calico. Doesn't seem like one will do anytime soon.
Certainly
Already
disk
labeled.
doesn't seem relevant to us.
Yeah, certainly disk doesn't seem relevant to us. I mean, maybe, I don't know what sort of network usage metrics they have in the node exporter, but I don't know. I generally am of the opinion that if there's already a simple open source tool that they can use to do this on top of Calico, like we don't need to reinvent the wheel. Unless there's like some serious problem with the node exporter, like it not being maintained or being super inefficient or something. This is not worth talking about. I'll respond to that later. When I use internal IP auto detection, get an error. So this is a new capability we added in the last release to base your IP auto detection based off of what the Kubernetes node API shows. And it looks like, for whatever reason, both nodes in their cluster are getting the same address, and Calico's complaining about that rightfully so. So this sounds like a maybe Calico's doing the right thing and picking what the node has, or maybe there's a bug in this new method. Oh yeah, I saw this one. This one's fun. I always enjoy a good screenshot in a GitHub issue. They're getting this error from the API server saying that the request we sent them is bigger than the max that's allowed. And that's because they're trying to use a block size with IPv6 of a 110 prefix, which is actually pretty big, 2 to the 18th or whatever. So I think we actually have validation in our code to say, yeah, must be between 116 and 128 to handle this exact thing. And they are bypassing it by editing the CRD directly. I think this is probably a case for CRD validation via cube builder tags. I think we can get, I mean, ideally they would be using the API server, which does this validation for them, but they're managing to slip around that. So we can just get our CRD to validate this field as well. So I think we do actually want to fix this one.
Probably want to fix it, but not quite how they want us to fix it, I would guess.
Yeah, we're not going to fix it by allowing them to make blocks that are whatever, have 27,000 IPs in them or something. Because as of yet, you can't really run 27,000 pods on most nodes.
Is it worth asking their use case?
We could ask. Usually when I've seen issues like this a couple times where people want to use really big block sizes for IPv6, and it's usually less of a real use case and more just I want to use a slash whatever per node because IPv6 gives me lots of addresses and I want to future-proof it.
I do know one sort of very vague possibility. It used to be the case that some hardware ASICs could only accelerate IPv6 subnets with masks of certain lengths because of limitations of the ASICs. I think it's unlikely to be that, but that's the only other reason I can think of. It used to be, and also I'm talking about used to be. This was when I was paying attention some years ago, so I'd be surprised if that's still the case, although it may be.
Yeah, could be, or at least could be like some remnant of thinking coming from that. Like I know we see people a lot that like don't quite get that we're not actually allocating a subnet per node. We're just allocating a block of addresses that are contiguous to the node. Like there's not actually layer 2 connectivity between the pods on that node. And that's sort of, it's tough for some people to wrap their heads around. So I've seen similar sort of feature requests based around that sort of thinking. But this one should be a quick fix. We'll get through a couple more of these and then we can move on. So it looks like there's some sort of inability to resolve external addresses. They've got wide open security group rules. Looks like core DNS isn't able to talk to whatever the node's name server is. But okay, that's interesting. Switching to a different name server helps. I mean, I'm guessing that the default name server for AWS is something inside Amazon. So that's sort of curious. Just gonna format this a little better. Anybody seen this sort of thing before? This one's kind of new to me. Cool, guess not. I'll have to follow up on this one. Right, so this person wants to advertise cluster IPs, but they're seeing that SourceNet happens. I think that's just expected and not really something Calico can deal with because it's a kube proxy behavior.
A few people seem to get burned by that one. Maybe we should improve the docs to highlight that that doesn't work because of kube proxy and not our fault.
I didn't follow this completely. Does it work in BPF mode without kube proxy?
I think so.
So that's a possible workaround then, is use BPF mode.
I'll leave it at that for now. And docs enhancement that we can do. Okay, we're at 9:30, so I think that's a good place to stop. Thanks for walking through that with me. There's one other issue that we just put a fix in that I wanted to call out. We'll probably do some patch releases soon for this. There was a WireGuard bootstrap race condition that could cause Calico's bootstrapping to deadlock, basically, with Calico node being unable to talk to Taifa. But we've got to fix in for that. I think it's been backported to 321, 322, and master. So we'll have patch releases coming out for that shortly. Otherwise, why don't we move on to a demo? I think we've got some multi-network early access stuff here. So take it away.
Yes, thanks, Gilly. So let me share my screen.
You should be able to. Let me. Yeah.
Great. So first, so this is just experimental. So let me show you the current state for multi-net in Calico VPP. So first thing to say is that we are using Mantis. So Mantis is running as a daemon set, and it acts as a meta plugin. So it's like a CNI of CNIs. It's a CNI plugin that can call multiple CNIs, other CNIs, and create multiple networks and attach pods to those networks. So first thing we did here is that we've added a CRD in Calico called network. So this is how our network is defined in Calico. So it has a name and it's defined by this VNI and this range to know how to assign IP addresses to the pods in this network. So here, for example, I have two networks that are created, one called blue and the other one called red with these ranges. Now, in terms of Calico VPP, in the agent, we have a component called NetWatcher that is going to watch the networks and to know about created networks, about deleted networks, updated networks. And when a network is created, this NetWatcher is going to tell VPP about that. And VPP is going to create a VRF table for that network. So we will have a table for every network in order to separate them. And pods in that network are going to communicate through that VRF. So here, for example, if we connect to VPP on this node, here are the tables we have. And as you can see here, there is a blue pod blue table, the pod red table for every one of the networks. Now, in terms of how Mantis defines networks, we have an object called network attachment definition. So this is how Mantis is going to know about the network and to attach pods to that network. So this is the attachment definition for blue. We need to have a config. In this configuration, we are going to specify the CNIs for the pods that are going to be created. So here, for example, we use Calico as a CNI plugin. And for the IPAM, we actually didn't use Calico because it doesn't manage overlapping networks well. So we wanted to have networks that have the possibility to be overlapping with their ranges. So here we use whereabouts as an IPAM. And in whereabouts in this configuration, we've added this network field to tell whereabouts that this should be in the network blue. So it's going to watch networks and to look for the network called blue in the CRD that we've created, and to look for the range to know where to assign IP addresses. So whereabouts is going to assign IP addresses dynamically across all the nodes of the cluster for the pods that are related to that network. So this is the network blue conf attachment, and this is the one for the red. Now, how Malthus is going to know what pod to attach to this network. So in the pod, so this is a simple pod. We simply add an annotation called networks. And here we can give the networks that we want to attach this pod to. So we can put as many networks as we like here in this list, separated by commas. So the names of the network attachment definitions. And in every network, we can put as many interfaces as we like. So in this case, for example, we tell Malthus sample pod 1, apart from being in the main network, we want it to be in the blue network with an interface called F1, and in the red network with an interface called F2. So this is a pod on node 1, and this is another one that I create. So I didn't create them yet. So let me create the 2 pods. So now these pods are going to be created, and they are going to be associated networks, interfaces in these networks. So let's make sure that interfaces are created and that their IP addresses are assigned. So on sample pod 1, here are the addresses, here are the interfaces. So F1 is created with this address 172.19, so just in this range for the blue network, and F2 in the red network with 172.21. The other one as well has the interfaces. So one interface in the main network, one in the blue network, and one in the red network. Now, the important thing about this is to make sure that pods of the same network can communicate with each other, and that interfaces of different networks are separated from each other. So let's connect to this one and try to ping an address on the other node. So this is a red address, so an address on the red network. And here the ping works because actually I configured the IP routes on this pod, so it knows which interface to use. However, if we specify this ping to start from F0, which is in the main network, the ping doesn't work. So this means that main network and red network are separated. If we do it from F1 of blue network, it doesn't work as well because networks are isolated from each other. So this is how pods communicate. Interfaces of the same network can communicate, and interfaces of different networks are separated or isolated from each other. Now, when it comes to VPP, communication between nodes of the same network is done through tunnels, through VXLAN tunnels. So let me show you how this is done on node 1. So here are the interfaces that we have. So this is the interface on the blue network. This is the interface on the red network. And these are VXLAN tunnels. So we have a tunnel for every network and a tunnel for every node that has a pod on that network. A last feature that I wanted to introduce here is memif. So when I created this pod, I actually created interfaces, and one of them has a name starting with memif. So this is a feature to create a MEMIF interface, given that we are using VPP. If we give the interface a name starting with MEMIF, then this means that you use the MEMIF interface. So on the MEMIF pod, this one is a MEMIF interface in VPP created on top of a dummy interface in Linux. So if we look for interfaces in VPP, here you can see that we have a MEMIF interface in the blue network. Now, if we want to test that interface, so MEMIF interface, it's just a shared memory packet interface. So we use it in VPP and it provides high performance. And to connect to MEMIF interface, MEMIF uses a socket and needs to have a client that is listening on that socket. So if we just ping this address of the MEMIF interface from the same network, it won't work because there is nothing that is listening on that socket. So to make it work, we just need to create a client and to attach it to the same abstract socket of that MEMIF interface. So to do that, on this MEMIF pod, I have VPP installed, and I'm just going to create a small VPP. So this is the configuration that is ready for VPP, in which I create a MEMIF interface, so a client interface that is going to connect to the same socket as my MEMIF interface. So this is the start tab, and this is the configuration. And now I start VPP. So here is the MEMIF interface attached to the same socket, and on the left-hand side, we have connectivity that works. Okay, so the ping works, and packets are received on the MEMIF interface. That's it for the features of multi-net.
Just one quick note. I mean, this is only experimental at this point, right? And we don't want to say that this is the exact way we want these things to be at the end of the day, right? But so the benefit of this demo is mainly to showcase how we can, one option to create, to give access to multiple networks, to multiple interface types, and isolated networks in separate verve. But yeah, we have other discussions to adjust, especially the data model, right? How the objects are stored and so on. But for use cases where people want a high performance data plane interface while sharing the same uplink, this is something we see as a very good candidate, right? In terms of seen from the pod perspective. Now, underneath, how we expose that to Kubernetes and to Calico, of course, there may be other ways to do that. Another benefit is that all this interface can benefit from Kubernetes services and policies, right? As opposed to models like PCI pass-through and so on. So there are, we see multiple benefits with that.
I had a question pop into my head midway about services in particular, and if you've thought about how those behave in a multi-network world like this.
Yeah, so it's not entirely obvious, but they will need to somehow be tied to a specific network, so that but like the endpoints for the service are selected in the right network, and the service is also reachable only from that network. Yeah, which is not really what services do in Kubernetes today. But we need to figure out what's the best way. So we can hack this, I think, in the existing API by using services without endpoints and then having our own controllers that populate endpoints for these services. But that means that clients can be true. Sorry?
Just on a similar note, policy, like Calico renders policy down to IP addresses. If you're allowing overlapping IP space, probably need to make Calico aware of that, so that if you say allow from such and such a label, you don't get IP addresses from the other overlapping one. That might be a
right.
Where,
so
like,
yeah,
you need a bit more integration to make that work rather than just the Malta stuff that you have.
Yes. So for this policy specifically, there are two levels. At the first level, we can consider that every network is entirely isolated from one another. And so even if we have overlapping IPs, the policies that apply to a network will be naturally like tied to this network, and that will make it a bit simpler, I think, for a start. Then once we start adding connectivity across networks, yeah, we're gonna need some more context basically in order to see what's allowed and what's not allowed. I don't think we can connect networks that are overlapping anyway, but yeah, that's gonna add a lot of complexity.
I think I guess I'm just thinking, if you have the overlapping IPs at all, like you could have a rule that says like allow from this label, deny from this other label, and if you have overlapping IPs, like unless you kind of modify the policies or things in namespace using namespace policies, you could easily pick up IPs from the other network. So like you allow from front ends, something generic like that. If you have two networks and they both have front ends in, you might have some IPs assigned in your red network that are actually assigned to backends, but your selector picks them up and gets confused. And especially if you have deny policy, it could get really confusing. Just thought of that limitation now.
Yeah, that's a good point. That's a good point. Yeah, I think I see what you mean. And
certainly,
yeah, we need to make sure we select workload endpoints specifically in the network that the policy applies to, and we don't consider everything else that's going on in the cluster somehow.
If you use if you're kind of naturally grouping things into Kubernetes namespaces and using namespace policy, be kind of all right for experimentation. But then if Calico is not aware of the different networks, it could get confusing.
Right.
I guess you could do something like put for sort of experimental purposes. You know, if we haven't integrated Calico with it deeply, you could do something like have an admission controller that sticks a label on the different workload endpoints or something. So, and then another one that kind of forces you to include a selector for your, I don't know, that feels a bit messy.
Yeah, that's a good idea. Yeah.
Just one clarification point as well, because we were Casey was speaking about a 3.23 beta version, and that is not part of it, right? Yeah, it's only experimental, and yeah, it's we are using it to try to see how we can do the plumbing of CNF, and in environment where we don't want to do SRIOV, right? But still having a extremely good packet performance, but it's not part of that. So we are starting working on a CAP with a bunch of different people on this topic, and see how things could evolve. But we wanted to show you that to you guys, and gauge your interest as well. I mean, do you see that of interest to you in the context for the community, for the Calico community, or any comments, or maybe it's too early?
I think it is something that comes up from time to time. I would say the the Calico philosophy has always been to avoid having like complicated overlays and everything if possible, but we do recognize that there are use cases where people need overlapping IPs, and like I think Nathan explained one time that was like it was really needed for that use case and that kind of thing. So we sort of our kind of very early architecture for Calico was, let's make sure that only the folks that really need that complexity pay for it and have the extra complexity activated in their network. That was the philosophy, I think. Does that sound about right, Casey?
Yeah, I was gonna say that sort of mirrors my head, where my head's at, which is like very cautiously interested. I know that there are certainly users who have asked for this and have use cases for it. They are not the set of users that historically we have kind of gone after. We sort of said that whole space is sort of out of scope. But like I'm interested in grabbing those users if we can do it without complicating the the 95% case. And so we have to just be very careful not to sort of pollute the experience for people who aren't using this sort of feature.
And really the alternative to, I completely agree with you that many customers probably don't need that, right? People who are deploying usual application don't need that, right? Now people developing CNF, right? Containerized networking function. Many of them need access to multiple networks, and really the only alternative is Multus with raw access to the NIC card, which is probably 10 times more complicated than that. That's actually, that is the reason why we did that. So if you compare to regular use case, yes, it's more complicated, no doubt with that, and probably it's completely useless. Now, if you compare that with, if you change the playground and now you go into CNF lens, I think it's 10 times simpler than what you would have to do otherwise.
I think the sort of model is reasonably like makes some sense. You know, you add the concept of a network in, and then pods or endpoints of pods get assigned to networks, and like obviously for the 95%, you have a default network and it just works for them. That's where I think we'd have to shoot for. And
yeah, I mean the sort of things that I'd be worried about are, one, like just considering this, considering every new feature as it comes in, how does it interact in this mode? It sort of adds a lot of complexity to the design process and problem space for some features. And then just like knowing users, somebody's going to misunderstand it and try to use it when they don't need to. Hopefully it's just one or two people, but like I'd certainly want to find a way to make sure this is tucked away and maybe like accessible and easy to use for people who need it, and hard to find and shoot yourself in the foot for people who don't.
Yeah, I've got one comment about that specific point actually, which is that there is a flip side to that coin, which is most routers that support multiple VRFs, they try and hide the fact that there is a default VRF and you're not aware. So the command line syntax of the device will entirely hide the fact that there is this VRF called default or whatever. And that can lead to some funky behavior issues when you're educating people, because there are certain things that you need to know, that there is this, the device actually has this multiple routing tables. Even if you've only enabled one routing table, you need to be aware that actually there are more. And I think we need to try to be very sympathetic to that as we would design we either take the line that Casey just said, where we hide it away. So, but that can bite you in just occasionally needing to understand that it's there, or confusing the heck out of people when they discover that there is this thing. Yeah. So the other thing is sorry, I thought it was cool. I don't love the construct, the resource construct being called a network. It feels to me like it should be called a VNet or a not a network. A network is a thing. A network, it already has a meaning. And to me, it feels like it should be something else, not network. But that's obviously.
Is that a naming issue, Chris, that you have?
Well, I just think it's analogous to what we're creating is something analogous to a VLAN or a VRF, right? And these things all
Yeah.
I don't know. It's at any rate, it's not something we need to answer right now. But I think getting these things right will enable it to be added in a non-intrusive way for other features.
Yeah, thanks for the feedback. It's naming it right is very important. I think it's a bit more than a VLAN because it also comes with this automatic addressing and a few features that we find in the Kubernetes network. But yeah, if any, we'll take your remark into account and we may rename it at some point. Yeah, thanks.
I wonder if it's the kind of thing where maybe there's a few integration points that we could make where we make small changes to Calico to make it more useful for these use cases. Like you said, that IPAM was unfriendly. Like maybe there's some way we can have an advanced mode of IPAM where it's namespaced and can be set up in that. I mean, that yeah, Casey gave a frown.
Just thinking
IPAM's
about
already
advanced
fiddly
mode of
enough.
IPAM is.
IPAM's already fiddly enough for us.
Yeah.
But I kind of wondered if it was the kind of thing where like 2 or 3 small changes and then like we can play nice in that environment, but I don't know if the changes would be small. Like things like introducing the concept of isolated domains for policy would flow through quite a lot of the code base. I think it's quite a big thing to think about.
Yeah,
I think that's yeah, sorry.
I think that if we could do it with a like sort of low touch to the common code path, you know, introduce a few touch points or additional features, and then like I think probably if you look at users who are going for VPP, the number goes from, you know, a couple percent to 50% or something, right? That are interested in this feature. So it makes more sense to highlight it there. And like I'm thinking even just things like, yeah, maybe the networks API is only ever installed if you're installing the VPP data plane. And so for
That's one nice thing. I mean, we can do that at our render level without touching the full Calico. But again, we are not yet there. On our side, we really want to continue to think about it and see what is the right model. There are tons of things which are not entirely clear. But we feel that there is a need. We've seen multiple use cases where there is a need for that because people who are running CNF again, they go where Kubernetes is just a bootloader for their application, and then they use SRIOV, right? And do we really want Calico and Kubernetes to be a bootloader, or do we want it to expose a richer network? Yeah.
Yep.
anyway, we are right at time now. So just wanted to
Thanks a lot for the feedback.
yeah, thanks for showing that off.
That was really interesting. Thank you.
Cool to see it in action. Yeah.
Cool.
Our next meeting is in May. I think the second Wednesday of May is the 11th. So I'll see y'all there.
Thank you. Bye.